force and torque is sometimes very important thing to measure. The way force and torque sensors work are they actually use a strain gauge. So once you touch that strain gauge on, say, some object, it'll bend or elongate. It'll cause a resistance change. The change in resistance can be measured to compute the strain, and we developed the formula for the strain as a function of change in resistance. Now, once you have the strain, so strain is computed, you want to convert to stress. The well-known expression for stress and strain is E times strain, or Young's modulus times strain. This is Young's modulus. And so you can now convert, given strain, you can convert to stress. But once you have stress, you can compute force. Force is stress times area. And if you want to compute torque, you need to do stress times area times the proper momentum. So this is very much dependent on how you are, how you've set up the device, right? The resistance, the moment arm will depend on that. And of course, the cross-section area. Now, when you look at manufacturer sheets for force or a torque sensor, you'll see it's written as millivolts per volts. What it means is that if you give a supply voltage of 1 volt, the denominator, it'll produce an output of, in this case, 2 millivolts. Okay, so 1 volt input, very tiny output. 2 millivolts is very small. So you might want to use an amplifier to amplify it. One of the things you need to remember is that these sensors don't come calibrated. That is, if you see a voltage of 2 millivolts, it doesn't mean that the force is 5 newtons. You need to first set up a process to calibrate them. So you put a known load, then compute then measure the voltage produced by the sensor, and then calibrate that whatever output to the no load condition, or sorry, the calibrated condition, and then go from there. A cheap version of force sensing is this force sensing resistor, which basically consists of just a sort of a thin filament, just almost like a strain gauge on which there is a sort of a resistance. And this wire, thin wire, really, the red one, has infinite resistance when no force is applied. Okay, so what you'll see is that if you connect this to a voltage source, then the current flowing through this is almost going to be zero because it has infinite resistance. Okay. However, when you apply a force, the resistance will decrease to 700 ohms. So now it allows some current to flow, which means that you can use this in a voltage divider fashion to measure the resistance. Okay, so once the resistance changes, that is usually measured using a voltage divider, something you've done in lab 1 or lab 2, sorry. Now, the problem with these force sensing resistors is that these force sensors have very low accuracy, although they are substantially cheap. I think you can buy it for a few dollars. I think I have a photo of these somewhere.